This is part 2 of section 8.5. We need to rationalize this. Well, first of all, when we were talking about simplifying radicals, one of our rules is that we're not allowed to keep a fraction under the radical. So I would need to switch this to the square root of 24 over the square root of x no matter what. Okay? Now I need to rationalize this, so I need to multiply top and bottom by the square root of x. And that will give me the square root of 24x over x, because we're squaring that and we get what's underneath. Okay? Now we need to simplify this. I know that the understood index here is the understood exponent here is a 1, and that's smaller than the understood index of a 2. So, and we've just found the square root of 24. We've used it twice on this page alone as 2 times the square root of 6. So this is 2 times the square root of 6x over x, and that is our answer. Remember, we cannot reduce these because this x is under the radical, so it's not a real x, it's some other value. This whole thing is our answer. Okay, so let's look at this variation where we have a cube root instead of a square root. There are, again, 2 different ways to work this. This first way, for actually both of these, we're not allowed to keep a fraction under a radical, so our first step in both of these is going to be splitting it up. So this is the cube root of 5 over the cube root of 16. Okay? Now, the main reason we have been multiplying by the denominator when we were doing the square roots is because if you multiply a square root by itself, if you square a square root, you get what's underneath, okay? And we've also talked about, this is a property from early on, that if you cube a cube root, you get what's underneath. Remember, if your index and your exponent matched, you got what's underneath. So what we're going to do here is, instead of creating a perfect square, we're going to create a perfect cube. So I'm going to multiply this by the square root of 6, or the cube root of 16 twice. Multiplying it by itself 3 times is going to give us a 16 in the denominator. But I need to do that to the top as well. Okay. So here we get that 16 in the denominator. I need to multiply 5 times 16 times 16, and that gives me the cube root of 1280. Make sure my fraction bar is long enough. Okay. We do not have the prime factorization of 1280. We have 1250, but not 1280. So let's do that. 1280 is definitely divisible by 2 because it's an even number, and when you divide that by 2, you get 640, which is divisible by 2 again, and you get 320. Divisible by 2 again, and you get 160. And I'm keep going with the 2's until I can't, which gives, this is 80, and then 40, and then 20, and 10, and then a 5. Okay, so we're looking for a cube root, so we're looking for 3 of a kind. That's 3 2's and another 3 2's, so a 4 is coming on the outside. Okay, and then we have 2 times 2 times 5, which is 20, left on the inside, and this is over 16. And then now we reduce, the 4 and the 16 reduce. If I divide that by 4, I get a 1. Divide this by 4, and I get a 4. So this answer, sorry, wrong pen, is the cube root of 20 over 4. Okay, so that's one method. Okay, now the other method. If you had happened to notice that 16 is a perfect square, it is 4 times 4. Okay? If you happen to notice that, our whole objective is to get a perfect cube down here because we had 16 times 16 times 16, which gave us 16 cubed, which is what enabled me to get to 16. If you happened to notice that 16 was a perfect square, then you can get this answer a little bit more quickly by simply multiplying by the cube root of 4. Okay, and this will give me the cube root of 20 over the cube root of 4 cubed, which is the cube root of 20 over 4, which is the same answer we got right here. Okay, this will always work, and you're not dependent on recognizing that 16 is a perfect square, but if you do happen to recognize that, then you can get there a little bit more easily. Okay, so we've talked about what to do if you have a simple radical in the bottom. If it's a square root, you multiply it by itself. If it's a cube root, you make sure you get a cube. And if it had been a fifth root, you would make sure you'd have a perfect something raised to the fifth power, and so on. You just want to match those. Okay, now for the second type of rationalization, the type where you have an addition or a subtraction in the bottom. I cannot simply multiply top and bottom by the square root of 3. That would make this go away, but then that would give me a square root of 21 here and a 3 here. And then when I multiply by the square root of 21, the square root's going to pop up over here, and it's just going to go back and forth every time I try to get rid of it if I try that method. It's legal to do that, but it's not going to rationalize the denominator for you. What we want to have happen is we want to multiply by what we call its conjugate. Okay, and to find the conjugate, you just change the number in the sign in the middle. So if I have a plus b, its conjugate would be a minus b. Okay, what we are actually going to try to do is we are going to be creating a difference of squares in the bottom. Okay, where we will have the same two values in the front, the same two values at the end, but opposite signs in the middle. What that will enable us to do is to square each of these, and then when we square a square root, the square roots go away. Okay, so I think of this as if it were in parentheses, and then I'm going to multiply top and bottom by those same two values, but since this is a minus, I'm going to put a plus in the middle. Okay, now I'm going to multiply across the top. You are allowed to distribute here, but I suggest that you don't, at least not yet, because if we end up being able to reduce this fraction at the end, you're going to have to factor the -4 back out. So no reason to repeat steps or undo things if you don't have to. So my numerator is this, and this is over. We have a difference of squares here, so we square each term with a minus sign in the middle. If you square the square root of 3, you get a 3. Minus. If you square the square root of 7, you get a 7. Now do that arithmetic. Three minus 7 is a -4. And now we reduce our fractions. You see what I mean right here? If I distributed, I would need to factor the -4 back out because those cancel completely. And your answer is the square root of 3 plus the square root of 7. That's your overall answer. Okay. Now let's do one more of these. I need to rationalize this. I have a subtraction in the bottom. So I'm going to multiply top and bottom by this, except I'll have a plus sign in the middle. So I think of this as if it's in parentheses, and I'm going to multiply top and bottom by the square root of x plus 2 times the square root of y. Okay, so in the top, that gives me 4 square root of x times the square root of x plus 2 times the square root of y. And this is going to be over. We do have a difference of squares here, so we square each term. If you square the square root of x, you get x. It's a minus because it's a difference of squares. When I square this, I square each piece. So 2 squared is 4. The square root of y squared is y. Okay? This doesn't reduce in any way with this. So this is a perfectly good answer. Okay? If you distribute, which is also a good answer, I would have 4 times the square root of x times the square root of x. So this is going to give me 4, and when I multiply these two together, I get an x, plus 4 times 2 is 8, and then when I multiply these two together, I get the square root of xy over x minus 4y. Remember, this whole thing would have to reduce with this whole thing up here. There's nothing I can do here. Either of these are perfectly good answers. Okay.